In this video, we're going to focus on the learning target of I can identify math properties. Our essential question, when, other than in math class, will knowledge of properties be useful? We have 4 math practice standards, 1, 2, 3, and 7. And the example we're going to do is a little different. We're actually going to create a foldable. What you will need to do is you will need to take your blank piece of paper. And this blank piece of paper is going to be folded almost to the bottom, leaving enough space that you could actually write something at the very bottom. Okay, it's going to go a long ways and it will flip up like so. Once you have done that, you want to take a pencil and you want to divide your paper up into 5 sections. Don't worry so much if they are not perfectly even. You just need to make sure you have 5. Each of these 5 lines that you've drawn, you are going to take a pair of scissors and cut up the line just on this top flap until you can actually lift it up and it be separate from the rest of the paper. Let me show you what I've already done. You can see I have our piece of paper. It's folded down. We have 5 sections, and I have cut each section so that it will flip up when I want it to be seen. Now what you're going to do after you've cut your flaps is you're going to want to write a caption on each of the cover flaps. Commutative property, associative property, distributive property, identity property, and zero property. Feel free to pause this video at any time so that you don't get too far behind with what I am saying and what you're trying to write. The first property that you are going to put on your foldable is the commutative property. And the commutative property basically states that 2 or more variables can be added or multiplied in any order without changing the sum or the product. I have several examples to show you, and you'll need to write those beneath the flap that you lifted. The first example I have written down is 1 plus 2 is the same or equals 2 plus 1, and you can see the sum of 1 plus 2 is 3. The sum of 2 plus 1 is also 3. I came down here with a multiplication example. 4 times 3 equals 3 times 4. And then the products there, 12 is equal to 12. I threw a little twist in and put some variables in for you. And if you look here, you can see that I have a plus b in parentheses plus c is equal to b plus a in the parentheses plus c. I switched the order of the a and the b, and it will not change our outcome. And then lastly, a times b is equal to b times a. Moving on to the second property, you have the associative property. And the associative property deals with grouping. For 3 or more numbers, their sum or product is always the same, regardless of the grouping. Here are your examples. I've done an addition example where I've used parentheses around the 1 and the 2, added to 3. And that is equal to 1 plus, and then parentheses around the 2 plus 3. Notice that the 1, 2, and 3 stay in the same order on both sides of the equal. The only thing that changes is the grouping. Here I have 3 plus 3 is equal to 6. Over here I have 1 plus 5 is equal to 6. The second example for associative property deals with multiplication. And I have 2 times 3 times 4 is equal to 2 times 3 times 4. You notice that the parentheses originally are around the 2 and the 3, and they move around the 3 and the 4. In the left side of the equation, 6 times 4 is equal to 24, and on the right side, 2 times 12 is equal to 24. Our third property is the distributive property. We're just going to briefly touch on the distributive property because you're actually going to do a little bit more with this a little later on. If you multiply a sum by a number, you will get the same result if you multiply each addend by that number and then add the products. That's a lot of words, but here's what it means. Looking at your example. If I multiply 4 times the product of 3 plus 5, I should get the same answer if I multiplied 4 times each addend and then found the sum of those products. You can see on the left side here, 4 times this becomes 8, gives me 32. And then over here, I did 4 times 3 is 12, 4 times 5 is 20, and then 12 plus 20 is 32. Both sides do equal one another. Our fourth property is actually a couple of different properties. They are the identity properties. There are 2 of them. The first one you have, and I really like to say it, although it's a very long word, is the multiplicative identity. And that basically means that if I take any number, any amount, and multiply it by 1, I'll get the same amount that I started with. I'll get itself. The additive identity has the same general meaning, except that this time instead of multiplying, we're going to be adding. And instead of adding or using a 1, we're going to use a 0 because we want to end up with what we started with. The additive identity says that any amount plus 0 is itself. 2 examples. The first example goes with the multiplicative identity, and it is 4 times 1 equals 4. And then our second example goes with the additive identity, and that is 4 plus 0 equals 4. The final property that we're going to be discussing and putting on our foldable is the 0 property. And the 0 property deals with multiplication. This time, instead of getting the answer itself, what you want to get is the number 0. And if you use the 0 property, any amount multiplied by 0 is 0. Here I have multiplied 5 times 0 to get 0. And then 1 million times 0 also gives me 0.